So let's go ahead and put together some of the things we've talked about already. Pause the slide and see if you can complete this reaction and write a molecular equation for it, a complete ionic equation for it, and then also a net ionic equation. And when you're done, start the voice lecture again and we'll go over it. Oops, ionic. Okay, to determine the products here, the first thing we've got to do is switch our ions around. And we have 2 sodiums and 1 sulfide and 1 iron and 2 chlorides. Now sodium and sulfide always have the same charge. Iron has a variable charge, but it has to be +2 because I have 2 chlorides which always have a -1 charge. After I've separated out my ions, I go ahead and I switch them and I figure out the formula based on the charge. Sodium and chloride have equal and opposite charges, so it's going to be a 1-to-1 ratio. Whoops. Let's see if I can get this a little straighter. And we know that sodium is always soluble, so that's going to be AQ. Now, let's look at iron and sulfide. I have equal and opposite charges there. And when I look at my chart, that's going to be solid because sulfide is insoluble and iron is not one of its exceptions. Now, I do need to balance my equation, and if I look over here, I have 2 sodiums and 2 chlorides, and I only wrote 1 sodium chloride. I need to balance that. When we're done with our molecular equation, it should be balanced. 2 sodiums, 1 sulfide, 1 iron, 1 iron, 2 chlorides, and 2 chlorides. So this is my molecular. Now let's look at writing out my ionic. To write out my ionic, I'm going to separate all my strong electrolytes into the ions. This is how they actually are dissolved in water. Since my sodium sulfide is AQ, my ions are going to be separated into 2 sodiums and 1 sulfide. My iron 2 chloride is also AQ, so that's going to be separated into 2 chlorides and 1 iron 2. On my product side, I have sodium chloride as AQ, and 2 of them, so I have 2 sodiums and 2 chlorides. I'll have to write my AQ underneath there. And then my iron sulfide is not dissolved, so it stays together. So here's my complete ionic equation. Now let's look at getting my net ionic. To get my net ionic, I'm going to use my ionic here. I have sodium as an AQ ion on both sides. Sulfide is AQ on the reactant side, but it's in the product on the reactant side. So that is involved in chemistry. I'm going to keep it. Iron is AQ on my reactant side, but it's in a solid on my product side. So that's involved in chemistry. I'm going to keep it. My chloride is AQ on both sides, so I'm going to eliminate that for my net ionic. So my net ionic is iron 2 AQ plus the sulfide ion AQ forms iron 2 sulfide solid. Now, when you are writing the formulas, it matters that the cation comes first. The cation always comes first in a formula. When you're writing these as reactants, it doesn't matter which comes first, but I always write the cation first because that's the order it goes in the product. And when you are writing the products for the complete or the net ionic, for the molecular or the ionic equation, order does not matter as long as you have a balanced equation and your states are correct, then the equations will be correct.